Welcome to, technology for embedded IoT. Dr. Marculescu and I had discussions about a year ago about how to make his course completely different than this one. I think we were successful. Surveys. Is anybody in both classes? Anybody in Marculescu's, Radu Marculescu's?
I am.
Yeah. Okay. So, as far as I can tell, there's going to be very little overlap. It's possible there isn't, but then again, I don't know what I'm going to do, and he doesn't. He's taught that his class before. But so Rita, going through, if you can see places where we could either be synergistic or not, go ahead and let us know.
Well, first class isn't until this afternoon, so I don't have any insight for you.
I know. I get it. We as a group, we're trying to figure out whether Radu's class would be major in architecture. I'm not sure we've decided that yet. This one clearly is. So that being said, I have one objective for today, and that is to give you enough information to decide whether to stay here, okay? You may, as a graduate student, you vote with your feet. I'm not intentionally trying to kick you out. I'm intentionally trying to give you my vision for exactly what we're going to do this semester in this class, so you can make an informed decision to stay here, okay? Obviously, I'm John Valvano. Okay, so another polling question. How many of you are new? Where's my, yeah. Let me go back to the thing here. How many, and any brand new graduate students here? Or,
yeah, I'm a graduate student.
Yeah, yeah, that's right. I met you in advising, so you're new. And any other new ones? Okay, so that means most of you know who I am. Okay, that's where I'm going. And so I won't spend a lot of time explaining who I am. I'll let you ask on your own. Okay, so welcome to Embedded Internet of Things. Now, I currently, in my office hours, have set this is the exact office hours in my 319K class. If the office hours get overwhelmed with 319K, I'll make special ones for you. This particular office hour is actually open to all students for advising. So this particular one may be busy because I've advertised this office hour to EE382 and 306 just in hopes that freshmen will figure out what's going on. As I said, this will be a major class for the architecture group. I was really nervous about 3 or 4 months ago until I found a book. Now, we'll probably go through about half of it, and just depending on how fast we go. And so you will see that the PowerPoints will have, copy pasted pictures from the book. I think, given the fact that there are some things I'm really good at and other things I'm not, I think the book will help you fill in the gaps with what it is I can't actually teach you. So I'd recommend the book highly. Okay, so where does this course fit? Okay, basically fundamental behavior of connected devices. Okay, and that's my PowerPoint for today, is to go through some of those connected devices, try to give you a sense of what it is you're going to do so that you can make an informed decision. This is the first 6 chapters of the book, by the way, of the Leah book. We'll spend just a day and a half or so on introduction, and then the first part of it will basically be embedded technology. We'll go through that fairly fast. That's essentially the 445L prereq in there. I chose the book because it had a lot of equations in it. Okay, so it's going to be a combination of, in lab, physical connections that you'll see in the PowerPoint, and then here in chapter 3 of this book, a bunch of equations about how this stuff works. Let's see. Again, I won't spend a lot of time on this because I got a whole PowerPoint on it. I do think, you know, it's something of the equivalent of 445L is something I'm assuming. I assume I'm not teaching you interrupts. I'm not teaching you A to D converter, D to A converter, or I'm not teaching you, I'm not even going to teach you operating systems. There are, you'll see, and when I get to the platforms, some of them have operating systems built into them. It is all in C. You could, or Arduino C, whatever that's called. Some of them have some Python coding. I will, since my handwriting is so sloppy, I will use PowerPoints. Reference designs. Okay. When I first designed this course, I thought we'd do this in the makerspace, you know, 3D printing and whatever, using the makerspace as the platform. Just because of the pandemic, I decided to go completely online, which means there's a shift of some of the platforms to things that are more lower cost, and some of the networks we won't do. As I do lectures, this should link you to a, yeah, so the question is, can you, does this link work? Yeah, poll in the audience. Can you click on that link and see my PowerPoints for today?
Yeah.
Okay, so 1.1 is what I'm going to do today. And so as a preparation for lecture, you could if you've already downloaded it, download it again, because I made a couple of edits on the first two. And then this is where my PowerPoints will show up. Once I get labs, there'll also be links for the labs, although yeah, I don't know quite how I'm going to link the lab assignments, but again, there's some PowerPoints on the labs. Yeah, here's groups. You know, it's you can do the, you know, labs 1 through 4 either by yourself with a group of 2. If there's some special situation where there's either an odd number of you or 3 of you, I'll negotiate if you really want to do a group of 3. But more about the labs in a moment. And again, I got some pictures of this. Pictures of this. Okay. I've already mentioned the OS's project. Okay. So what isn't in this class? I don't know anything about clouds. So, and I don't know anything about machine learning, so there won't be any of that. Let's do this. No final exam, 40% on your project. I can't see. That's not it. I still can't see. Where's the chat? There, no, still can't see the chat. All right. For very simple laboratories, and we'll sort of talk about them in a moment. 3 exams. Yeah, we were told to make more exams shorter. I don't know. You're grad students. I don't know if you're really anxious about something, please reach out to me. You know, email me, whatever. But it's not meant to be stressful. You can see the due dates are going to be weird, and that is because I have a finite number of platforms. Okay, let me. I know. How many of you are out of town? Let's do another. Let me see here. Any of you out of town? In other words, you couldn't go to EER, pick up a lab kit, do the lab, and return it?
I'm out of town.
You're out of town. So we're gonna, okay, so I'm sorry, I heard you, I didn't see you. Who's out of town?
Keyshawn, hello.
Keyshawn.
I'm out of the US.
You're out of the US, so 2 of you.
Yeah.
So we're basically gonna figure out some way to get you a kit. and so that you can do the labs. The rest of you will basically sign up, go to EER, pick up a kit, whatever, however it's done, do the lab, and return the kit. Okay.
Can we buy our own hardware?
Oh yeah, sure. You absolutely can. No. You'll see. Well, let me get. So the question was, can you buy your own part? Great question. Obviously, and actually, each of the labs has got a completely open-ended option where you could do a lab on whatever. Okay. So yeah. So that's a. So I have two of you. The parts aren't that expensive, so we could potentially get you what you need. Okay, so grading.
Are the exams hard?
I hope not. Let's see, who is, some of you have taken exams from me before. So so the question was, are the exams hard? So I know a lot of your faces, either because you were TAs or in my classes. So unmute yourself and tell the class what my exams are like. Come on, read it. I mean, you guys, some of you were TAs.
I don't remember the exams.
Okay, so they weren't so hard that you're traumatized by them, right?
Debatable.
Okay, so
Maybe I've just blocked it out.
They weren't that bad.
I don't know.
As long, if you did all the practice tests, you were fine.
Yeah, but obviously you've got no practice tests, right? That is a situation.
Oh no, you're right.
Yeah, there's a brand new class with no.
That's a panic button.
That's the problemo, Dr. Valvano. We got no practice exams.
I know it. So maybe that'll. Okay, so let me pose the question in a different way. Okay, some of you know my personality. All right, let's go that way. Would you say my personality is empathetic or sadistic?
Empathetic.
We're on the scheme of that.
Yeah, he's empathetic.
I'm empathetic, so yeah. So if I think I understand your basis. I don't think you should. I mean, okay. What's the objective of today?
To hash out the class.
You hash out the class. I wouldn't either take this class or not take this class based on the exams. Okay, let's go on. I mean, it's not a filtering device. Yeah, it's a grad class. You know, if all goes really poorly, you could get a C, but that's unlikely if you do the assignments. Okay, all right, so enough of that. Any questions on the syllabus?
So just to clarify though, for all of the future lectures and PowerPoints that you come up with, you're just going to add to this. It's kind of a living document with all of the PowerPoints and things, the links to them.
So, yeah, so can you see my screen?
Correct.
Yeah, they're the first three PowerPoints.
Yeah.
Okay. Yeah, so, yeah, I think I gave you access to I mean, I might give you read-write access to the labs. I was thinking I'd do that and let you guys fix my lab situation. That's my plan is to, this is basically where I built the class, and I haven't shown you but a couple of these, right? But, when I get to the labs, I think I'll just give you read-write access. That way, if there's a typo or a question, you can put a comment in the lab right itself. That way, when I answer it, everybody gets there. All right. Any other syllabus questions? All right.
I'm curious about the workload of this course because I'm already having 3 courses.
Okay, fine. No, workload. That's what I'm about ready to do. Okay.
Okay.
Yeah, that's what I'm about ready to do. And that is, obviously there's no workload to lectures. The workload is in the labs. Okay, so there are 4 sort of simple labs and 1 project. Okay, and so this is to explain to you what those labs are and what they will look like. Because of the fact that each platform, I don't have 18 of. I mean, I have, you know, I have like 4 of these, and I'll have 3 of these. I don't know. I'll have 4 of these, some of which I only have 1 of. The due dates for the laboratories are open-ended, which means that all 4 of them are due in November, whatever. There's a date here. Right before Thanksgiving, which means that if you are a procrastinator, this is not your course, because you know, you really have to schedule your time to do the first 4 labs. Yeah, so that's the overview. Okay, so let's talk about process. So you will go to, I don't know, you will go to checkout, or you will buy on the internet, whatever, a lab setup. Okay, this is half of the sub-gigahertz lab. Like I said, there'll be signups and sign-ins for the checkout. You will then install software. All the software that I envision will be free. There might be some other applications to install, and then you'll run starter code. And so my job is to create starter code for each platform that does something so simple that it's enough to realize you have the hardware working and the software working. You'll take some simple latency measurements. Now, you're gonna have to find yourself access to something that can measure time delay. So either a dual trace scope, or one of these extremely low cost logic analyzers. And this, the link for this is in one of the previous Canvas emails. And if you added the course late, all my emails are announcements in Canvas. So on the Canvas a couple of announcements ago was a link to buy something simple. Now, of course, you don't have to buy something simple. I mean, I love my analog discovery, you know, but it's like $250. So you'll need access to something that can measure time delay on 2 digital signals, either a logic analyzer or a dual trace scope. So you'll measure with the starter code, you'll measure something simple, okay? Sometimes that's latency, you know, how long does a packet take to get? Sometimes that's information per second. And now that's, I actually don't need a logic analyzer for that. You can just use software. Do you lose any packets? Is there power? How far does it go? And so those should be fairly straightforward measurements on the existing code. And then you'll make some small change. So you got to and the whole point is the change will illustrate that you understand it. Okay. And then we'll have some sort of Zoom session where you can show me what you did. And then in the actual lab report, I think it's got a maximum of 2 pages. Okay. So these are 4 labs that are should be fairly straightforward, especially if you have a partner and you got somebody to help you. Now, each of the labs is, you know, there isn't one platform, there are multiple platforms. And so you'll see the platforms are either different because they have a different microcontroller or different because they have a different wireless IC that does the communication. They may be different because they have a compiler, okay? Some of them are Arduino based and some of them are Code Composer Studio. Luckily for you, I'm pretty good at Code Composer Studio. So over the years, I didn't start out good at it, but I'm good now. What the device does is a variable. Some of them are fitness devices, right? You measure acceleration. Some of them are robots. Some of them are just buttons, okay? Some of them are just buttons or LEDs, relays, whatever. The other variability is the OS. They're in the example files so far, you will see either there's no OS, it's bare silicon. It runs an OS like 445M, which is a simple RTOS, or it's TI RTOS. Yeah, let's see. Let me ask the audience again. How many of you, it's not a requirement, but how many of you had 445M or whatever 380L.12? Yeah, so 1, 2, 3. Yeah, some of you. If some of you are, is anybody taking it now? Yeah, unmute yourself if you really have a question, or you're just saying yes. Your hand is raised, Rita. Anyway, in the starter code for this is actually a solution to 445, but it's on a different platform and a different compiler. It won't help you really. Okay. Okay, make small changes. So yeah, so what are so let's go down 1 through 4.
I got a question.
Question, yeah, go ahead, speak.
So if we're gonna all, like, I have some SparkFun like IoT devices that I plan to use for the Wi-Fi. So is there like no right answer? Because that obviously, like, the power draw on that will be different than like a TM4C.
Of course, there's no right answer, nor is there, and I don't care about maximum bandwidth. I just care about bandwidth. No, there's no, well, he said, is there a right answer? No, clearly not.
Okay.
Yeah, so yeah, actually what you've identified an actual problem with this class, and you'll see it in the second PowerPoint, is there are billions of devices out there, literally billions. You or I can't possibly know them all. And so, and I don't own any TI stock or, you know, Norton, you know, Semiconductor or whoever who makes these chips. And so I don't care what platform you use. And so you will see for each lab, there will be a set of steps. Okay, so let me just walk you through, say, the first lab, and that is you'll take 2 of these systems. It has an MSP432 on it and a Seed Studio HC12. That's this thing down here, this picture here. You take 2 of those, and then you'll push a button on one and it blinks a light on the other. Okay, and that's how simple it is. You will measure latency. You don't have to maximize bandwidth, but you got to measure it. You can measure power, because all you got to do is put a current meter on the red wire here and measure the power. If you happen to use a CC1352, it'll be completely different. But what you'll do is install the compiler's IDE, download the starter code, run code on here, and modify it a little bit. Okay. One of the cool things about sub-gigs is it's pretty much a bare platform. And so one of the small changes, if you'd like, is to design your own protocol. You know, address, packet type, packet payload, checksum, whatever, and then on the other node send an acknowledgement. And so again, I don't particularly care how simple it is, but you will basically write code on the in this case MSP432, or in this case over here the Arduino. So you write code on this Arduino here that develops a platform. They're designed.
If your board is integrated, like the one shown on the bottom right, do we just take the power measurement of the entire board?
I don't care. Whatever you can do. It turns out one of the things you can do with Code Composer Studio is have it measure power, by the way. That's actually a button in Code Composer Studio. Yes, or you can put a current meter on the jumper chip right here. Okay, so they're these little black jumpers. You can pull it off, put a current meter on. And again, it goes back, is there a right answer? No. I just need you to know what power is, right? You know, power is current times voltage, and energy is current times voltage times time. And it's way complicated because these things go in and out of, sleep mode and etc. yeah, so I don't preclude that even if all 18 of you did the lab on the same chip, you wouldn't get the same power. But yeah, I want you to know power is important. Figure out how to measure it. Okay, either average power or use a tool in the IDE. So that's the advantage of the of some of these more integrated devices, is they have they have ways to sort of instrument the device. On the other hand, the downside of this is you got to run TI-RTOS. And that's why this is not an undergraduate class, because I don't know if you've ever, I'm just warning you, in a real operating system like TI-RTOS, you can't necessarily figure out what's going on. You can create a thread and it gets run, but it does abstract a lot of the low level. For example, those of you who have had 445M, in TI-RTOS, I have never figured out where the thread switcher is. Remember those 10 lines of assembly code that flip threads? I haven't figured that out. And nor should you this semester, okay? You need to be comfortable using tools like TI-RTOS, like C compilers, like debuggers, like oscilloscopes or logic analyzers, voltmeters, current meters. Let's see, how am I doing on time? Okay, a half hour in. Okay, so for each particular lab, like I said, you will download the code, you will install the compilers, download the starter code, run the starter code. That gives you confidence that whatever you have is wired up, and then modify it a little bit. Okay, so there are 4 labs like this. As you can see, some of these labs, you can't change any wires at all, right? I mean, some of them are open-ended like this, where you can add stuff or whatever, and some of them are pretty closed, in which case you just use whatever hardware is on there. All right, so that's sub-gigahertz. That's the one, that's the long-range one. The simple one, that's the one onto which you can design your own protocol, okay? And so getting back to those of you that are either in another place or want to use your SparkFun crap, I need you to design your own protocol, okay? And so if you can use a Zigbee platform and design your own protocol, that works, because Zigbee is also open-ended. But if you put your protocol on top of something else, you're not designing your own protocol. I want you to design your own protocol. However you can figure that out, either by using these or, okay, let's go on. Bluetooth, now we're hitting the next 2 that I have quite a bit of experience with. So let's do these one by one. This is a, okay, it needs a wire, it needs a battery and a cable, and that is a fitness device, okay? It's got a MSP432 launchpad for where you write code. It's got a CC2650 that implements Bluetooth low energy as a set of functions that you can call. And it has this cool booster pack called the Mark II, which has accelerometer and a temperature sensor and a joystick and a screen and a buzzer and a microphone, light sensor. What else is on there? Sound? Whatever, a bunch of sensors, and runs Bluetooth. We did this as a, Yarabali and I did this as a MOOC lab. Okay, so tens of thousands of people across the planet have done this laboratory. It's, the Bluetooth is somewhat abstracted because it's implemented on this board and, sense of function calls. The second place that I've done Bluetooth is in the robot. And so the robot down there, it's a robot, so it's got motors and sensors and bump sensors. This is the new sensor that it'll have here. It's a time of flight sensor. We tried to get it onto 445M last semester, but the pandemic hit and we never got it in there. But it's a time of flight, not laser. It's optical. It's infrared. But there's software drivers for it. But the IoT part is a Bluetooth launch booster pack. You know, this thing down here, this Bluetooth launch booster pack. And again, the Bluetooth low energy is implemented on this chip here, wherever it is. So where to go? Yes. Yeah, over here, that one. Okay, there's the Bluetooth chip. Implemented there. The what you call it, the antennas there, and then you write MSP432 code functions, which interface through the serial port to control Bluetooth. The robot doesn't have an operating system. The booster pack has an operating system. Let's see, what are there? Lots of Bluetooth stuff. This same board that did sub gigahertz, did IEEE 15.4, also does Bluetooth. And so this is an example of where a single platform could do 2 labs. Okay. Let's see. I don't have it here. It's over and across the room, but there's a picture of it. McDermott built for us a SparkFun based Nordic semiconductor Bluetooth module. The only downside of this, I only got one of them. I have a second PCB, so if somebody wants to learn Nordic, potentially solder up a second one of these. I have the parts for another one, but I may make a second one by the time I get there. That was Bluetooth. Anybody got any questions about either sub gig or Bluetooth? Yeah, so basically you check out a key, write some software, do some simple measurements, and then change it a little bit. For instance, in Bluetooth, you can add characteristics, right? You can add more data channels. That's an example of something I'll have you do in the Bluetooth low energy. So you don't have to write it from scratch. You start with a starter code, you understand it all, and you change it. Now, Wi-Fi gets to be more open-ended and more possibilities, okay? One possibility, it's shown in the picture, this down picture, is the same robot we saw in the Bluetooth could also take a Wi-Fi module. And what I did, what the laboratory that I envisioned for this combination here, this one with the robot and CC3100, is you basically log robot data through if this then that type of server. It shows up as a Google Doc. So data collected while the robot doing something is pushed onto a web page using if this then that. Let's see, the MSP432 with a CC3100 without the robot, that's more open-ended. You can either push stuff to a web page, you can push stuff to a if this then that. Those of you who are in 445L know that the ESP8266, we've got code that runs Blink. And so, I'd rather you learn something different than you did in 445L. But if some of you want to learn Blink, Blink is a way to make a very general purpose. Anyway, make a very general purpose cell phone app that runs across the internet. and you can design a cell phone application and deploy the IoT device. And now the simplest thing for Valvano is to use the ESP8266 because we already got starter code. But okay, and then again, McDermott left us a Wi-Fi board. Again, I only have one of them. I got a blank board, but I only have one of these built. It uses the ESP12E, and it does Wi-Fi. And again, download the compiler, download the starter code, check out the kit, run the simple code, change it a little bit. Now for each of these, I don't intend you to do them all, right? I just do one. As a matter of fact, let me go on to number 4. This one's even more open-ended. My thinking about this is what if there's some other platform some other thing that okay, so for each of these, you have the option of adding your own platform, okay? I'd rather you learn something than just regurgitate something you finished. And for each of these, you can add your own platform, okay? And so those of you not in Austin, that's what we're going to do next, is to figure out what platform you want to do labs 1, 2, and 3 on, and we'll figure out a way to get you a kit, okay? Either you buy it or I ship it to you or whatever. Some of this is export controlled, so I don't know how I'm going to get, but that's a long story. We'll go offline. And then in lab 4 is even most open-ended. Unfortunately for me, the GSM lab that I have runs on on level 2, and Sprint is gonna mothball that in December, and so that's this thing here. And so I'm not sure quite what I'm gonna create it, make it happen. And just so to get you to realize how hard this is to be, for this particular lab, your objective is to send text messages, okay? So create an IoT device, create an IoT object that sends text messages to your phone. The other platform that I've seen and had students use before is near field communication. I have 2 of these kits with the TI part. That's a MSP430, so it's not an ARM chip. It's a RISC chip, but it's a 16-bit low power chip. And basically, this module, one of these 2 modules, is completely powerless. So there's no battery. It's a batteryless device, and you basically take these 2 boards and you place them together, pulls power and communication off one to the other. So if you want to learn NFC, and then if you want to learn something completely different, you're welcome to propose and set up a lab. Now this one's actually not bad, because all you got to do is figure out the instructions for the compiler, get yourself a kit, make some starter code, and so next year when I teach it, it will be one of the options, okay? And so that's your objective here in lab 4, is to add more labs for me for next year. All right.
Is RFID one or no?
Say it again, what?
Is RFID one?
Well, this is an RFID. Yeah. So there will be the RFID is, so RFID, powered RFID. Yeah, that's what this is. So if you want to use an RFID platform other than this one, yes, that would be fine.
Like if we have like one of these fobs that we use to enter our apartments, and then a reader and stuff, could we use that and like?
You can program it? Can
Yeah,
you
we can
program?
program. We can
Yeah,
program
sure,
it.
totally. Yeah, no, totally. So, yeah, so you would, one of the assignments for other is to basically write me a lab assignment. So you could take the lab assignment I have for this board, edit it for your board, you know, and let me buy some for next year. Yeah.
Cool. Okay.
No. Yeah, as a matter of fact, if you do it early enough, I'll buy it for this year and let the other students can use it. That would be fine. Yeah, so if you're going to do that, I'd encourage you to do 4 before you do 2 or 3. That way other people can do 4. Yeah. Yeah, once it works, show it to me and I'll buy some for the class. I don't care.
Can I skip exam 3 if I do that? Is that a possibility?
Well, you can, okay, so, all right, so it turns out I've already negotiated what you can skip. We're in negotiation. It depends on how much work you do. Yeah.
I'll do an extra lab. Can we do an extra lab to not take an exam?
Ooh, okay. This is somebody, where's my video here? That's somebody I know. Who's talking? Okay, where's my thing? Somebody's. Okay, it's Keyshawn. All right, yeah. You guys are in, okay. The rest of the 17 of you are in great shape because I've had Keyshawn before, and he will keep me. Yeah, it may sound like he's annoying right now. I promise you, Keyshawn, you're not. Yeah, he will negotiate something. Oh yeah, totally. I'm in. Yeah, I'm in. I don't know.
I like labs, not tests. I'm willing to
no,
do
that's
10 more labs if I don't
so
have to
you want a
take any.
lab 5. Okay,
I want a
so
lab.
you
I
have
want
to
an
do-
optional lab 5. Yes.
Yes, an optional lab 5 to either replace. Okay, because that way we can do it that way. We can, let's say you take exam 1 and don't like the score.
Mhm,
Ooh,
mhm.
yeah.
Replaces your lowest exam grade.
Yeah, let's. Yeah, so you're in. Yeah.
Is that done deal?
Yeah, sure. I'm you know, nobody cares. Okay. There is no final exam too, by the way, Keyshawn. You notice?
Yeah, I know that. Thank you for that. Thank you.
Yeah. So, yeah. The only trouble is exam 3 is late, but you could do okay on the first 2
And then skip, get a 0 on the third one.
and get a 0 on the third one, but you have to do a 5th lab.
Or you can take, if you don't want to do the third or 5th.
Oh yeah,
lab,
no, you can just
take
do.
all.
Yeah, you don't have to do a 5th lab. Yeah, sure. It probably needs to be different than your project, so you're not double dipping. But yeah, we'll work on something.
Cool.
Yeah, you and I will make it. Yeah, sure. So
Okay, I'll get lab 4 done with you for you in the next couple weeks then.
yeah, sure. And then we'll. But doing lab 4 for me is lab 4, right?
Yeah, just to like have it available for other
Yeah.
people.
So and then let me buy some parts and I'll put it in checkout.
Cool.
No, it's good. Yeah, the same thing. Yeah. So yeah, Austin, you're here. You're also, you know, negotiated doing a lab 4 for me, right? Too. I think. Yeah. So anybody can participate in this, not just Keyshawn. All right. Yeah. See that's fine. I don't mind making things harder for you. It's way harder to do a lab than to take a quiz, by the way. But just for those of you who workload issues. And now here, I don't particularly care how many people are in the project. You know, I'm thinking 2 to 4. If you've got a group of 4, you're probably writing a cell phone app or a web page. My intent is for you to, so Keyshawn, if you do a lab 5, you're doing just the bare minimum. Simple starter code, simple measurement.
Yeah, it's just a different chip, right?
Just a different chip.
Like Zigbee.
Whereas the project can use one of the chips you've already done, but now you're extending it in a significant way to solve an actual problem. Make measurements as appropriate. We'll do a class presentation during the last couple of weeks of the semester, depending upon how many groups I get.
Is Zigbee different than the first
No, Zigbee is a Zigbee is an example of you could do Zigbee here. Okay, so
what would be an example of like a fifth lab?
if you do this and Zigbee, right? You can do Zigbee two ways. You can do Zigbee in place of lab 1 and not do, not do seed 11, or you can do seed 11 and Zigbee if you want.
Oh, okay, that sounds good. Okay.
Yeah, you gotta do 4 labs and 3 quizzes, or 5 labs and 2 quizzes. All right.
But does Zigbee? This is just like a theoretical question. Does Zigbee fall under sub gigahertz?
Yeah, sure. Yeah,
Okay.
it's an 802.11.15.4 protocol.
Okay, yeah.
Yeah, it's low power, low bandwidth, long distance. Okay.
Okay.
That's how you sort 802.15.4. Okay. And sometimes the frequencies are not in the less than a gigahertz, but most of them are. Okay.
Cool.
Is that to answer your question?
Yeah.
Okay, let's keep going here. I'm open-ended my project. Okay, so yeah, you got to do a class presentation. I don't know, 20, 25 minutes of this is what it is. This is how it works. Maybe a YouTube video of it working, or a live demo if you're brave. If there's 2 of you in the group, you don't have to do a cell phone app or a web page development. As you saw, most of the platforms have hardware completely done. Okay, whether that be relays on the purple boards or motors and sensors on the robot, or sensors. Well, the robot also has a display. Sensors and display on the Mark II. So I don't require you to solder anything or interface any chip, either hardware or software, because the starter code has the drivers for the devices. I don't expect you to write cell phone apps. I personally have written Android apps. As a matter of fact, this particular platform here can be controlled by my Android. Now, it's not something you have to do. You see it up there, not necessary, but if you, now I was supposed to learn how iPhone apps last semester with my senior lab team, but the pandemic hit, we stopped meeting and they never got around to showing me how their cell phone worked, your iPhone development. I've not done iPhone apps. Now, if we do Bluetooth on the iPhone, we'll run a, okay, turn robot on. Hold on. Okay. Bumper plus bumper to start. Right, so the robot's running. There is a simple iPhone app to control Light Blue, to control Bluetooth. And so when you do the Bluetooth lab, you're going to use a cell phone and run an existing app. See there, no, come on, where is it? Come on. Oh, there it is. You see, it showed up. The bottom one, Jackie. That's the robot. I don't know if you can see Jackie on there. All right, shut this off. Well, I'll have demos of the labs going forward. So those are things that you don't necessarily have to do: web page development, cell phone apps. But like I said, if you got a group of 4, you're got to figure out enough for 4 people to do, and so you might be writing an app or a web page or soldering something. Things that you're not going to do only because I have no idea how to do it. So I'm not going to teach it to you, nor would I be able to evaluate what you do, is new ICs. And so this is not an RFIC class. Ranjit Japuri, if you want to learn how to do RFICs, you take a IC class from Gapuri. I know neither how to do it or how to evaluate it. let's see. We're going to look at antennas. We're going to say, oh, that's a pretty antenna. We're going to show you. You know, we're going to go, oh yeah, that's a pretty antenna. You know, that's a pretty antenna. One of the things I did do, and we'll talk about it when we get to that part, is design coil antennas. It's not really an antenna, it's really a coil because the frequencies were low. But we're not really going to design any antennas. I don't consider if this, then that cloud storage. I mean, obviously it goes to the cloud, but it's not, you know, it's not really cloud storage. And I don't know anything about machine learning. So I'd rather you didn't put machine learning in your project because I won't be able to understand it. I mean, if you have to, but it's not something I want you to do. But what I do want you to do is understand how it works. Okay, that is, if you were to clarify what this course means, I would like your IoT device to be so simple you understand most how it works. Okay, you are going to write lots of C code. Yeah, it's probably going to be important for you to deploy an OS in your project. Now you don't have to write the OS; you're just going to have to deploy it. And obviously, there's lots of I/O because this is a IoT device.
You mentioned something about, I mean, Python. How does that play into?
One of the okay, so this one here, in this lab here, a MSP432 and any microcontroller and a Wi-Fi chip can do a put, you know, a TCP packet put. Now, where does it go, right? So you could write a web page. In 445L, before we went to Blink, kids wrote a web page. So they basically Python code, uploaded to some Google server, and ran Python to decode the web page. Now, that's not something you have to do because, I don't know, you can use IFTTT or Blink, but it's something you could do. So Python is what's running on the internet.
Okay, so we can write like a Python server and
yeah,
collect packets that way and
send packets. Yeah. So that was, is that you again, Keyshawn?
yeah.
Yep. So yeah, so your IoT device does a TCP put.
Yeah.
And then somebody has to
Receive
get
it.
it, right? So it has to receive it. So yeah, this is the client. These are clients, and the server is the internet somewhere. That's the essence of Wi-Fi.
All right. Cool.
Now, yeah, it's possible. I mean, these devices could also be servers. I don't have starter code for it, but the IoT device could also serve. But yeah, I don't.
Would that make it interesting to you to use?
It's all interesting to me, you know. So okay, so why am I teaching this class, you ask? Okay, that's because I'm 66 years old and bored, right? I've been teaching 319K forever. Now 445L, you know, it really does excite me. And yeah, it's been a long time since I taught a grad class. The last grad class I taught was just to show you how weird life has gotten. The last grad class I taught was medical instrumentation. So all sorts of analog hardware, digital signal processing. Yeah, it's 32 down here. Yeah, this is the last. Yeah, look at, it's been 11 years since I taught a grad class. Yeah, so yeah, what is this class? Yeah, those of you who know me know who I am, right? Who am I? I'm a guy who loves embedded systems. I'm a guy with analog circuit skills and signal processing skills. I'm not necessarily a guy with a lot of IoT. I've done maybe 3 or 4 systems that would be classified IoT. There's actually a slide on that. That's lecture 3 of showing you the stuff I've done. Okay, where was I? Sorry, get back to work here. I got to finish this. I'm also scatterbrained, and that's why I use PowerPoints. All right. All right, open-ended project. Yeah, question. Any questions on the project? All right. Yeah, 4 labs and 3 exams, or as Keyshawn would point out, 5 labs and 2 exams. And is that enough? Hopefully that's enough information. I've got another Zoom meeting at 11 about the ventilator, but I do have office hours tomorrow. If you want to, I will be around a little bit after class, or you can ask it right now, actually. Is there anything you need to know to stay in this class or not?
I guess for me, because I'm one of the remote guys, like, what do you mean by kit?
Okay, so,
Like, do you just mean like those TI kits?
yeah, this is a launch pad that does both sub gigahertz and Bluetooth. Okay. Yeah. So
So if I can just buy my own chips, do we not worry about that?
no, yeah, no, totally. Yeah.
Okay.
Just you can just.
Okay.
I just
yeah.
don't need you to spend a lot. Yeah, absolutely. So
I'll go ahead and get them on my end, so don't worry about me. Yeah.
okay. So that's what I'm happy to encourage you to. Any other questions about whether to stay? It's just my friend in China. You're in China? Is that where you are? Or where? Let's go back to the. Ma, where are you? Suya Ma?
Yeah, I'm in China.
China. Okay, so, yeah, you're my special case. Now you can be partners with Suyan. How do you pronounce it?
Suyuan Ma.
Suyan Ma. Okay.
Yeah.
You can be partners with Suyan. That's not a problem because you basically can help each other. Set up a GitHub or whatever, and Google Drive or whatever, and share code. He can be in your projects. You can give him stuff to do. Check out together. Yeah, just that I don't. You and I are we're gonna sit in office hours sometime and figure out how to get you a platform that does the core inventories. Okay.
Well, I found that these things can be bought on the website and they can be mailed.
All right. So, yeah, I'm not sure I can put kits in a box and mail them to you. Is what I'm trying to. But let's work offline about how I'm going to get you. So yeah, raised questions. So, yeah. So Rita, is your hand raised for a particular reason?
I raised my hand.
Okay, so go. Yeah.
Yeah, I have the class looks super interesting, but I think I'm overcommitted for the semester. Did you say you'll be offering it in a year?
Hopefully, if I, that's my plan. Yeah, it'll be better. Yeah, no, please don't drop because it'll be better next year. Yeah. Yeah, if you want, yeah, so Branch, if you want to drop and then email me, I could add you to the Canvas so you can see what we're doing. But yeah, it's a lab class. Yeah, so the rest of the, at the undergraduate level, okay, who teaches the course that's the most workload?
You do.
I do, so
No,
yeah.
I'd say Compark. Compark is worse.
Or Pat.
Okay, fine.
We've
worked
better
really
the
hard
ASIC track for sure.
Yeah, we've made it really hard to be, yeah, McDermott and I, to get below Compark in 445L because we don't want to be the hardest. When I taught that other grad class, the kids were so sad about how hard it was that we made it a 6-hour. I'm the only one to have taught a 6-hour graduate class. That was back in my young days when I thought this was the only class. This is not going to be 445L intense. I mean, look at it. What are you? You don't have to design any hardware. The software starter code should work, and then you modify it. Okay. So this is not going to be 445L hard. That's not my intent. But it is a lab class branch. And so, yeah, I would intend this to not be a light workload, but not micro architecture, not even 445, computer architecture 1 hard. And not Matan hard. Anybody taking a class from Matan? Yeah, it's not going to be that hard. Yeah, not my intent.
It seems reasonable.
That's the plan, I don't know. Okay. Any other questions about, I have a PowerPoint I can do. I do, what time is it? I have a PowerPoint. Yeah, let's see. I got a PowerPoint. Let me, more. Jason.
Yeah, I just had a real quick general question about course logistics. Are we planning on having some sort of forum like Piazza or something? Because I would like to have a lab partner in the future, but.
Oh yeah, no, good idea. Piazza. Yeah, we could let's do Piazza. Piazza.
Okay. Yeah, just something for general questions.
Yeah, because I get the 319K Piazza post. I get the MOOC Piazza post. That way I get an email and I can go and answer it. Now I don't have a TA, so it's
just you.
Well, I don't know. I just see how many people are here. I don't know how many. Maybe I hope not too many people couldn't come because, yeah. So I don't.
No worries. All right. Thanks.
Yeah, Piazza. Good idea. Any other logistics questions? All right, let's go back to. Yeah, my plan was to. So, again, my objective was to show you enough stuff so that you could decide whether to take it. Okay. All right, so this PowerPoint is essentially chapter 1 of the book. And I can summarize this PowerPoint in one statement. There's an awful lot of IoT devices, okay? So that is the objective here. There's a lot of money to be made. There's a lot of jobs to be gotten. There's a lot of businesses to start. There's a lot of impact to be made. That's what you should glean out of reading the first chapter of the book. Okay, your reading assignment for Tuesdays, read the second chapter of the book. Okay, but there's a lot of impact. Now, this is Leah's definition of an IoT device. These 4 things, or 3 things and a not the 4th thing. It has to be computational capable. I was looking up a Turing machine. And so a Turing machine, as you know, could be completely mechanical. So I don't think that's what he meant to be computational capable. I think what he meant was an embedded system, an embedded microcontroller, which had a processor, software, and memory. Now, he divided out the connections in 2 ways, both logical, in other words, sending packets, sort of a high-level communication protocol. Now, he used the word internet in his definition, but if you look very carefully, there will be a bunch of labs 1 and 2 don't have anything to do with the internet, okay? Labs 1 and 2 are directly connected to other IoT devices, so subnets within each other. Here's where I'm going to defer even in Leah himself. A lot of his devices aren't connected to the internet; they're connected to each other. But nevertheless, some sort of communication protocol, some sort of physical connection. Interesting. Does it have to be wireless? Not necessarily. For instance, Ethernet is not something that I planned a lab on, but I do have boards that do Ethernet. And so you could potentially wire up a platform that fits into this category of IoT that's actually doesn't have any wireless at all. You know, I'll make this point when we get to the slide on the military devices. They don't like wireless because of the security reasons. They like it, but they don't like it. Okay, so there has to be a physical transport. That's the essence of chapter 3 of the book. And then Leah goes on to classify laptops, servers, cell phones, tablets as, you know, Xerox machines, printers is not IoT devices. And so, yeah, I'll poll the audience. Yeah, what do you think? You've come into this class kind of already knowing what an IoT device is. Would you consider a cell phone an IoT device? So, yeah, raise your hand or unmute yourself, however you want to do it. If you think your cell phone is an IoT device. Yes or no? What do you think? Yeah, okay, yeah.
No.
Thumbs up or thumbs down, that'll work too. Yeah, 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 no, okay, no. Yeah, you can see, yeah, you know, you have 150, I don't know, some yes, some no. What this actually identifies is a problem that all engineers have in terminology. And that is whenever you write a technical report, you're going to use a word. And that word has a context and a definition that's not necessarily agreeable on. And so, yeah, as a communicator of engineering technology, it behooves us to not only say this is an IoT device, but say, I define an IoT device as, and therefore it is. Okay, so that's my plan about that one. It's been around a long time. You'll see from the next plot, it really exploded around 2000. This is one of the fun examples, 1993, that I thought was an actual application. Is the University of Cambridge had a engineering building that was wired up with communication protocol. It wasn't the internet, obviously, in 1993, but there was one shared coffee pot in the building, and they, yeah, if you're up on the 4th floor and want to go down the 2nd floor and get coffee, it would be nice to know if anybody made any for you. So most engineers like to drink coffee, but very few like to make coffee. And so this was an interesting application. Yeah, obviously, this is essentially home security, right? Back in 1993. Yeah. The next 4 or 5 slides all say, yeah, this is a big deal. And the cool part about the book, it was published this year. So even though this particular plot obviously was built in 2000, was created in 2015, there's a lot of updating in the book for 2020. You know, so obviously this is publications, Google searches, patents applied for. Yeah, and these are, yeah, these are large numbers. Okay, again, another 2015 data point. Again, this is in billions, okay? These were projections for, it's like watching Back to the Future. How well did these people predict the explosion of IoT devices? And pretty well. So these were market surveys on potential 5-year plans, 5-year projections for IoT devices. Yeah, no matter how you count it, it's billions. Another one, growth rate. This is year-to-year projections. And the interesting thing about this is the comparison of human growth rate, right? So, yeah, the world population, which is the blue, which luckily for the environment isn't growing exponentially anymore, but hopefully we'll survive this pandemic with most of us still alive. Yeah, but there are two IoT and again connected devices. They're obviously including cell phones in this data. So I would think most people are going to include cell phones as an IoT device and how they define it. But there is an exponential growth beyond, greatly outstripping well, obviously these are projections, greatly outstripping the human. And so I asked a rhetorical question, this is sort of a science fiction horror movie. At some point, humans are not going to be in control of things. Yeah, in order for this exponential growth to go on, the computers are going to have to program themselves. So if that's scary, then my charge to you as a group is embed some ethics into this. Okay, so that's really what you as the people who will actually make this happen have the ability to drive this phenomena into a goodness. Make agricultural devices that grow crops, make cars that have lower energy. Don't just make bombs. Okay, that's my
quick question on the graph.
Sure, go.
What is the Ericsson IHS differentiation?
Well, I mean, just this is growth rate. This is year over year.
Yeah.
Means how many more you gonna have?
What's the difference between orange and gray?
Two different projections.
They're different
One's
projections.
Ericsson,
Okay.
one's IHS. I don't know what they.
Okay, just different projections. Okay.
Different obviously they're projections, right? This graph was probably made in 2015, and so just projections. It's just you can look at this is actual data, right? And patents and publications. So yeah, it's
yeah. The words in parentheses just didn't mean anything to me at that time. So thank you for clarifying.
Okay, so check the clock. Okay, so this class ends it now, and so I'm going to go ahead and stop here. I'll pick up from here on Tuesday, but I'll open again for anything come to mind. Okay, is there anything in the chat?